This Tecumseh ignition program will cover many subjects from the basic theory of ignition systems to the proper timing procedures and ignition troubleshooting. Understanding the components and their functions can help to troubleshoot on ignition systems. The first item needed to create electricity in the ignition system is a magnet. There is a magnetic force field sent out between the north and south poles of a magnet. When a conductor is passed through this force field, electricity is generated. This conductor is the soft iron sheets that form the core of the system. The lamination core is riveted to the stator body. When the north pole of the magnet is in line with the center leg of the laminations and the south pole aligns with the left leg, the magnetic force fields are routed through the conductor's center leg. As the magnet continues to rotate, the north pole aligns to the last leg of the core and the south pole is then located at the center leg. This reverses the direction of the magnetic force field through the center leg of the lamination, creating electricity. This electricity passes through a primary core of copper wire wrapped around the center leg. Let's take a look at how Tecumseh winds the coil primary. The primary is formed by winding copper wire a specified number of times around itself. The spray that is visible is acetone. This allows the wire to adhere to itself and form the core. To increase the voltage to an excess of 15,000 volts at the spark plug, a secondary winding of copper wire is required. The wire in the secondary winding is thinner than most human hair. The wire is soldered to the terminal connection. This connection transfers the electricity from the primary to the secondary. The spindle will wind 35 secondaries at a time. The machine automatically cuts and inserts the paper insulator between every layer of wire. There are approximately 75 layers to each secondary. The breaker points of the engine serve two functions in the engine. First, they stop and start the flow of electricity in the primary of the coil. When the points are closed, electricity flows in the primary. When they open, the flow of electricity in the primary is forced to the secondary windings. The voltage is increased and sent to the spark plug. The second function of the points is spark duration at the plug. The wider the point setting, the longer the spark is available at the spark plug. This ignition cam is the device that opens and closes the points. The cam has a high spot called a lobe to open the points at a set degree for the engine. The position of the magneto keyway in the crankshaft is what sets the dwell in the engine timing. The cam wiper is a piece of oil-impregnated felt material that lubricates and cleans the cam. Re-oiling of the wiper is not recommended. It is best to replace it. The condenser acts like a shock absorber in the electrical system. The condenser takes a charge and holds it until it is discharged. The charge of voltage is always the same. This prevents arcing at the points. The center of the condenser consists of two strips of foil separated by an insulator. The foil is tightly wound and placed inside a paper insulator so that it doesn't ground out against the condenser body. The flywheel key is the device that properly positions the magnets in the flywheel to the magneto system so that the electricity is generated when it should be. When the 15,000 plus voltage is sent down the line, it exits at the electrodes of the igniter, known as the spark plug. The gap at the electrode also determines the way the engine will run. If all of these components are put together, a complete standard point ignition system is formulated. There are several forms of solid-state ignition systems. The type that is going to be explained in this program is Tecumseh's capacitor discharge ignition, or CDI. Every manufacturer has a variety of systems and circuitry to achieve the same result. However, the same basic theory is used. It all starts with the rotating magnets in the flywheel passing the iron core laminations. This produces AC voltage. There is a diode in series to convert the AC voltage into a pulsating DC current. The DC voltage charges the low-voltage capacitor. The capacitor serves the same function that the condenser does in the standard point ignition system. An electronic switch called an SCR turns on and off to unload and load the capacitor. The SCR is controlled by the small amount of voltage that is produced in the trigger coil of the module. When the SCR discharges the capacitor, the voltage is sent to the primary of the transformer. There is approximately 190 volts in the module at this point. That 190 volts moves into the secondary windings of the coil and is stepped up to as much as 20,000 volts. The 20,000 volts is sent to the spark plug to fire the engine. The basic operating theory of standard point ignition and CDI solid-state ignition have been shown. One of the most important things to remember is that the ignition system is totally independent of all charging systems.
Excuse me, sir, what are you doing?
Time out.
What are you doing?
Timing this engine.
You're out of here. We're going to talk about ignition timing today, but not in that sense. We're going to deal with timing solid-state ignition, the externally mounted coil with fixed-timed engines, and of course, standard point ignition. The simplest engine to time is the engine that is equipped with the externally mounted CDI solid-state ignition. The only tools that are required to time that engine are the 670, 297, 12.5 thousandths air gap gauge. You take the air gap gauge and place it between the flywheel and the solid-state module. You then rotate the flywheel so that the center of the magnets and the center leg of the lamination stack align. Once they have aligned, you can then loosen up the bolts holding the solid-state module to the engine. The magnetic pull of the flywheel will draw the laminations of the module to it. Once they've been drawn tight, you can then tighten up the screws again for the module, and then rotate the flywheel so that you can remove the air gap gauge. One item you do want to check is you want to turn the flywheel to make sure that the magnets are not striking the laminations of the solid-state module. Another area that you want to make sure you have checked is that this engine uses a gold-colored flywheel key. The next engine that we're going to talk about will have the externally mounted coil and points and condenser underneath the flywheel. That engine will use a gray colored flywheel key. When working with the engine with the externally mounted coil and points and condenser underneath the flywheel, it's as easy to time as solid state ignition with a few steps that we're going to show you. We have already removed the starter cup and flywheel nut, and as you can see by looking at the cord holes on the flywheel, we have used a flywheel puller to loosen the flywheel. It is very important that when working with two-cycle engines that you do not use a knockoff tool because of the needle bearings and ball bearings in some of the applications. After the flywheel has been removed, you can loosen the dust clip and remove the dust cover. If you're servicing this engine for the customer, of course you're going to change the points and change the condenser. After you have changed the points and condenser, to properly time this engine, rotate the engine so that the rubbing arm of the points is on the highest point of the ignition cam. Once the rubbing arm of the points is on the high side of the ignition cam, you can set your points. Now with the externally mounted coil, the point setting on all engines is 20 thousandths. You can loosen the screw that holds the points down, and inside the stator body there is a casting so that the blade of your screwdriver will fit in there so that you can move the points out or move the points closer together so that you don't have to bang and push and pry the points open and misalign them. Now a thin blade feeler gauge generally works considerably better than the wide blade that I'm using now. But you set your points at 20 thousandths and tighten them up. I think a common complaint that I often hear is that the points have a tendency to spread when you tighten the screw back down. So you do have to be somewhat careful when you tighten them down to get them tight enough to hold, but not to force them out. And as we set points, we're all going to have a different feel on the feeler gauge for 20 thousandths. After the points have been adjusted, you need to clean them. So you can use a piece of lint-free bonded paper. The edge of currency works well as long as you don't get the green ink onto the point. So put the white edge in there, close the points, and draw the paper through to clean your points. I don't believe in using point cleaner because many times the contact cleaner that is used is to remove the oil from the contact points. The problem there is that when you spray it in there, you can also be removing the oil from the cam lobe wiper that's in there to oil the cam. So using contact cleaner is not a good idea. You can then place the dust cover back on and the clip. Now on the two-cycle engines that have the externally mounted coil, we use the same flywheel for both two-cycle and four-cycle engines. In two-cycle engines, we use a gray-colored sleeve adapter. Put the sleeve adapter into the flywheel and press it down flush. There are two tabs inside this adapter that now act as your key. So align the adapter to the keyway so that the two tabs are in the keyway. Place your starter cup on and properly position it. Make sure that the crown on your washer is up and put your flywheel nut on. One of the most important tools that you will have as the service technician is a torque wrench. So make sure when you're working on any engine that you have looked up the specification for the flywheel nut and always torque the flywheel nut. After you've torqued the flywheel nut down, again, take your 670-297 12.5 thousandths air gap gauge, place it between the laminations of the external coil and the flywheel. Rotate the flywheel so that the center leg of the lamination stack, and the center of the magnets align. And as before, loosen the bolts up and allow the lamination stack to be drawn to the magnet. You tighten the mounting bolts back up, rotate the flywheel, remove the air gap gauge, and again, check to make sure that your magnets are not striking your lamination stacks. An important thing to remember when talking about this externally mounted coil, if in your testing and checking with ignition testers you find that this coil is bad, you must be aware now that you will receive a 730-207 solid state ignition kit. The coil has been obsoleted, so you will get solid state ignition now. When you get solid state ignition and you have a 2-cycle, please make sure to remember to order the gold sleeve adapter. The gold sleeve adapter does not come with the 730-207 kit. Now you have timed the engine and it can be put back together. That's the next simplest engine to time, is the external coil, points and condenser underneath the flywheel. The final area that we want to address in ignition timing is the standard point ignition. The best place to start with timing and standard point ignition is in your mechanic's handbook. Turn to the proper section, chapter, and book that you're going to be using. Take your model number of your engine. The engine we're going to time today happens to be a V60. So in looking in the book, we find that V60 is located in reference column number 13. And turning to reference column number 13, we find that the before top dead center timing dimension is 80 thousandths before top dead center. We also find that the point setting is 20 thousandths. An important thing to keep in mind is that not all engines have a point setting of 20 thousandths. Let's take a look in the 2-cycle book to show you an example of that. Now, as you scan the 2-cycle book, you will notice that not all point settings are 20 thousandths. Let's take a few moments and talk about point setting as it relates to timing. For every 1,000th that you're off on your point setting, your timing is off 5 thousandths. As we set points, we all know that we have a different feel on the feeler gauge for points. Your setting may feel like 23 thousandths to you. It may feel like 20 thousandths to me. Or to the gentleman here, it may feel like 17 thousandths. So it's important to get a consistent point setting and to time the engine. In looking in the manual, we also know, as we've looked up, that the V60 engine that we're going to time has a timing dimension of 80 thousandths before top dead center. Let's take a moment and use the word that so many of us have always been told never to use, and it is not a 4-letter word, rather a 6-letter word, and that word is assume. And we know what assume does to you and to me. So let's assume for a little bit what will happen to an engine if we assume they all have a before top dead center timing dimension of 80 thousandths. And looking in the book, we find an engine that is set at 60 thousandths before top dead center. We're now 20 thousandths out of time by an assumption. And then the feel of the feeler gauge, which may feel like 20 thousandths to me and be 23 thousandths to you, we have a difference of 3 thousandths in the point setting. So therefore, we have a difference in timing dimension of 15 thousandths there. That gives us a total difference of 35 thousandths. The engine can be out of time that far just on point setting and not looking up the before proper top dead center timing dimension. If that 35 thousandths is advanced, that's the engine that when you pull the recoil, it kicks back and it jerks your arm out of its socket, and we're all real thrilled about that. Or if that 35 thousandths is retarded, boy, that engine starts great, but it just doesn't have the power that it should when it's running. So changing the points and condenser in the engine and the proper timing is to use the proper timing dimension, because the statement has been made so many times is, all I changed was the points and condenser. So therefore, I don't have to move the stator plate. All I did was change the points. Well, changing the points can throw you completely out of time with the engine. So it is important. And let's go back to the bench and go through ignition timing of the standard point ignition. After the flywheel has been removed from the engine, we can then get to the ignition components. First, we want to remove the spring clip that holds the dust cover onto the stator assembly. We can then change our points and our condenser and felt wiper for the cam lobe if necessary. We're going to point out some things that are important during this presentation that many times are overlooked and can cause ignition problems as far as timing goes. One of those areas of concern is many times the ignition cam. The ignition cam has a giveaway that tells you the direction that it goes in. If you look on the ignition cam, it will tell you top. So therefore, it goes in so that it says top is on top. We have seen at times when the ignition cams have been put in upside down and the engine is 180 degrees out of time. After the new points and the new condenser are in, let's begin to time this engine. Now there are a number of ways to find the high side of that ignition lobe. If the engine is out, many times you can reach underneath and turn the crankshaft of the engine by hand to find that high point. Or if you take the key, place the key back into the keyway, you can then use a wrench. Or one of the other ideas passed along to us by a servicing dealer was to take a connecting rod, cut the cap in half, place a washer between the leg of the rod and the cap, bolt it back together, and use the washer in the keyway to help turn the crankshaft. They all work well. Vice grips and the likes on the taper of the crankshaft is obviously not a good idea. So now we have rotated the crankshaft in the engine so that the rubbing arm of the points are on the high side of the ignition cam. It's now time to set our points again. And just as before, we can loosen the adjusting screw. This is a 4-cycle engine. We've looked in the manual. We found that the point setting is 20 thousandths. And again, we can use the boss in the stator body so that we can tighten the points. Now if you pull that feeler gauge out of there and it snaps, you know that your points are a little bit too tight. So loosen them up and again reset your points. Setting the points should be done with a feeler gauge. It should not be done with the old business card trick or the matchbook cover. Those things do not condone good point setting. So make sure that you do use a 20 thousandths feeler gauge if it calls for a 20 thousandths point setting. After the points are closed, we want to find the proper before top dead center dimension. The 670-241 dial indicator is the tool that we highly recommend for you to use. It comes with a thick leg up here in the adapter collar, and it has a thin leg on the, or a thin tip on the leg of the dial indicator. When it comes to you, this leg will be straight. One of the service tips that may help you is what we do is we take this leg off from the dial indicator, put it into the vise, and put about a 10-degree bend in the leg of the dial indicator. Then I use the thin tip, and the reason that I put that bend in the leg of that dial indicator is so that when you have the heads with the higher fins, especially in the 8 and 10 horsepower engines, you can then get the dial indicator into the spark plug hole of the engine. Then when you insert the dial indicator, make sure that the leg on the dial indicator is over the piston. A number of technicians out there have been known to measure valve travel instead of piston travel in the engine. I always place the dial indicator in probably 1 to 3/4 inches or thereabouts so that I know I have plenty of travel on the dial indicator to find my top dead center dimension. The one thing you must remember is that all of our engines from the magneto end run in a clockwise rotation. So therefore, to find the proper top dead center dimension, after I have set my points on the high side of the cam, I like to turn the engine counterclockwise just a little bit. And then I turn it clockwise until the needle on the dial indicator stops and changes direction. The point at which the dial indicator stops and changes direction, where it stops is top dead center. You can then loosen the dial on the dial indicator and zero it out. Now we want to go 80 thousandths before top dead center with this engine, so therefore we must turn the engine counterclockwise. I turn the engine past the 80 thousandths and then turn it back clockwise to 80 thousandths. The reason that I do that is it takes any play or slop that there may be from wear and time in the bearing surfaces out of the engine. It's coming back up on the compression stroke. Now the next item that you have to find is, when do your points open? Because as discussed in the theory portion of the program, when the points open is when the engine fires, and now you have the 80 thousandths timing dimension set, and that's when you want your points to fire. To find out when they fire, there are several items that you can use to find that opening. Some of them are what are called a buzz box. You put the earphone in and you listen for a tone change or the buzzing to stop completely, and that tells you that your points are open. You can also do that with a voltometer to find that continuity break. I prefer using the continuity light so that when the points open and close, you get a definite feeling and way of telling you that there is contact made or not made. So I prefer using the continuity light. One important area to remember when using the continuity light is that you have put the nut and washer back onto the point post terminal. A lot of fellas put the points in and do not put the nut and the washer back on. And the problem that happens there is that when you do not have the proper spring tension onto the spring of the points, your point air gap and point setting can change as much as 3 thousandths. So we go back to that dimension that we talked about before of every 1 thousandths of your point setting being 5 thousandths in the timing dimension. If you don't have this nut and washer in place, you're talking up to 15 thousandths out of time once you tighten that nut and washer back up onto your point post terminal. So when you're timing the engine, make sure that you have the nut and the washer on that terminal. Another important thing to remember is to know your equipment. There are some continuity meters that are set up to bypass the condenser when it's in the system. However, my continuity light is not, so therefore I have to make sure that the condenser is disconnected from the point post terminal. Otherwise, the charge from the battery will charge the condenser and I will not get a definite difference in my continuity meter when I hook it up. Take one end of your continuity meter and hook it to the point post terminal. The other to good ground on the engine. Now you can see in this case I have continuity already through my meter. If you don't have, I've been asked many times, how do you know which way to rotate the stator? Well, you can see that by rotating it completely in one direction, which happens to be on this engine counterclockwise, there is no continuity. So then you have to rotate it back until you do have continuity. From that point, you then want to rotate the stator until the light just goes out. At that point, you can hand tighten the screws. Now my light came back on again. Contrary to popular belief, you can in fact use a hammer on an engine, but we're going to show you how to use it correctly. We're going to fine tune with this hammer, and that doesn't mean beating the daylights out of this stator. So we'll tap a little bit that way. You can see the continuity light went out again. We'll tap back that way a little bit and back the other way. Now it doesn't take a strong force to do that. You may find that as you tighten up the stator bolts, the light may come on, but you can check to see where the engine is firing. Simply reach underneath, take the PTO end of your crankshaft, and rotate the engine until the light goes out. Now this one happens to be going out a half a thousandths off. In other words, it's firing at 79.5 thousandths before top dead center. We like to see you when you time engines to be within 0 to 3 thousandths plus or minus in your timing dimension. However, the engine will run and run properly plus or minus 5 thousandths from that timing dimension. Once you have set the timing, you can disconnect your continuity meter and take an 11/32 wrench. The reason I mention that is 11/32 is generally considered an ignition wrench, and that's the size that you need for the nut on the point post terminal. Take the nut and the washer off, route your primary from your coil and the wire from your condenser underneath the dust cover clip, so that the dust cover clip can hold your wires away so that they do not rub on the flywheel and cause the engine to short out. Put your washer on. If you have a stop clip for ignition ground, make sure you put that on, and then put your nut back on and tighten them up. A common mistake that's made in ignition timing is that after the technician sets the timing, a lot of times they want to go back and reset the points. If you go back and reset the points, then you have to retime the engine again. Rotate the crankshaft so that the rubbing arm of the points is on the high side of the cam. Again, take your lint-free paper, put it in between your point terminals, close the points, and clean them. Again, not recommended to use the point solvents. Can then loosen the adapter, remove your dial indicator from the spark plug hole. Make sure in this case that you turn the adapter and not the dial indicator, because the screw that's on the end is a self-tightening screw, and by turning the entire dial indicator, many times that leg and tip and screw will end up in the combustion chamber. So make sure you turn the adapter sleeve and not the entire dial indicator. Place your dust seal back on and your spring clip. And that's all there is to timing the standard point ignition engine.
Troubleshooting an ignition system can be rather frustrating for some technicians. By reviewing the basic theory of ignition systems and the importance of having the engine properly timed, a lot of these irritating situations can be resolved. There are a number of problems that may appear to be ignition related and are not. Let's take a look at some of these. When the engine backfires through the carburetor, the first culprit to blame is always the ignition system. In order for an engine to backfire through the carburetor, one condition is always present. The engine's intake valve is open. Therefore, a number of checks must be made to pinpoint the exact problem. Number 1. Is the intake valve warped, burned or carboned up so that it is not seating? 2. Is the camshaft properly timed to the crankshaft gear? The scribe mark and hobbing hole must be in line with the chamfered tooth or dimple on the crank gear. The only exception to this rule was the old Craftsman engine with the ramjet carburetor. Another important thing to remember with the valve timing is that sometimes the sudden stop to an engine does more damage than just shearing the flywheel key. Camshaft teeth have been known to break, as well as the crankshaft gear. With the pressed-on crank gear, it sometimes spins on the crank. The correct location for this dimple or chamfered tooth is approximately the 2 o'clock location when the journal is at 12 o'clock. An easy way to check this without tearing the engine sump apart is to watch the valve action as the piston moves up in the bore on the compression stroke. This will allow you to see if the fuel is getting in too soon or too late. Third, as mentioned earlier, is the flywheel key sheared from a sudden stop? Has the proper flywheel key been used, and has it been positioned properly? And finally, has the engine been timed properly? If the timing is advanced, the engine will fire while the intake valve is still open, causing backfiring through the carb. There are several ways to check for spark. Let's look at the safe ways. The safest way to check for spark is to hook up a spark tester to the lead wire and to the plug. A hot, bright blue spark should jump the gap. If the spark is orange or yellow, the engine will not fire under compression. Checking some solid-state modules without having the secondary of the unit grounded can cause failure to the unit. If the engine has been taken apart, there are a number of suitable testers to check the components. The use of some of these testers will be shown later. It is not a good idea to check for spark with the lead wire disconnected from the spark plug. The possibility of shock is great. An extremely dangerous method that should never be used is to remove the spark plug and check for spark. Gas will be sent out the spark plug hole, and any type of spark or flame could ignite, causing a fire. Never use this procedure. If a spark is not present, make the following checks. Has the control been moved to the start or run position? Is the engine ground wire damaged? Has a bare spot been rubbed in it, causing the electrical current to ground out? When it's possible, isolate the engine from the equipment. With the numerous safety switches in use, it's possible that they may be at fault. If this is the cause, all new ignition components and your time won't help. A faulty key switch can also lead to a grounded ignition system. In some cases, with a bad switch, battery voltage will be fed back up the ignition ground wire and destroy the electrical components. Double-check the wire on the equipment and the polarity of the battery. Reversing the polarity will also destroy the ignition components. Another instance of no spark may be in fact that the magnets have lost their power. It is very rare that the magnets lose their magnetism, but it can happen. The only practical way to check the magnets in a repair shop is to place the flywheel on a wooden surface. Grip a long screwdriver by the handle. Move the blade of the screwdriver to within 3/4 of an inch of the magnets. If the blade snaps to the magnets, they still have sufficient strength. In checking the flywheel, make sure that it is not damaged. While looking at the flywheel, if there is a crack to the right of the keyway, that indicates a severe sudden stop. If the crack is to the left, it is a sign of improper torque to the flywheel nut. Never reuse a damaged flywheel. The statement has been made that the engine is backfiring at the muffler. Flames are shooting out. This condition is generally not an ignition problem unless the timing is so retarded that all of the fuel in the combustion chamber is not being burned. The excess fuel is sent into the muffler on the exhaust stroke of the engine and is ignited by the heat of the muffler. This condition is generally the result of too rich a carburetor setting or a leaking exhaust valve. Timing a Tecumseh engine properly is critical. An engine that is out of time just will not perform satisfactorily for anyone. An engine that has the time too far advanced will kick back, possibly causing injury to the operator. An engine with retarded spark starts easily but lacks power when it needs it. When the engine is timed properly, it will start easily and respond to the power demands of the equipment. We have mentioned a number of conditions to look for when troubleshooting ignition systems. Well, how do you check the actual ignition components?
Good evening. Thank you for joining me this evening for a very enlightening, informative, and very interesting game of ignition checkers.
We're going to take some time and talk about electrical testers and not ignition checkers. And we want to talk about some of the things that you should consider when buying an ignition tester. We're not going to tell you today that this tester is better than any other tester, but what we are going to talk about and give you some guidelines that you may use to select a tester. There are a couple questions that you need to answer in your mind about ignition equipment before you purchase it. What can your shop afford? Test equipment is not cheap, but by the same token, don't buy cheap test equipment because it will not give you the results that you want to know. Another important question is, what do you want the equipment to do for you? Do you need to know what the series resistance is in the coil? Do you want to know how many microfarad your condenser holds? If so, then perchance you'll want a piece of test equipment similar to the one here that has the needle indicator and will give you those readings and the scales to read them. If that's the type of test equipment that you prefer, then this may be the style that you want to purchase. If your concern is the equipment or the component good or bad, and that's all you want to know, then you can buy a couple other versions of the testers that are either a go, no-go version, and there are several styles available on the market. Another thing that's important when looking at test equipment is to in fact find out what will the test equipment test. Not all the test equipment will check solid state ignition as an example. So there's no sense in making that investment with today's day and age of solid state ignition if your component tester will not check solid state ignition. So make sure that your equipment will do what you want it to do. Now, in a couple of the major lines of test equipment, Tecumseh has produced and provided the test manuals for both the Mercatronic and the Graham Lee product line. As you can see on the screen, the part number for those books is available. Another important book that Tecumseh has produced, and that's the Ignition Troubleshooting booklet, which again may help you through some of the tough ignition questions that you may have. Let's take a couple moments and show you how one tester works real quickly, which is the go, no-go type tester. The unit that I'm going to demonstrate today is the Graham Lee 31 SMXH. The tester is relatively easy to use. You connect the probes as the color key shows on the tester. You can turn the tester on, and by looking at the amber light on the tester, you can see that you have continuity. Let's make a relatively quick and easy check on a coil. The short wire with the eyelet on the coil is the ground. So we hook the black lead to the ground. We can hook to the primary of the coil and see that we have the amber light glowing again. That tells us that we have continuity through the primary of the coil. If you disconnect the red lead and touch it to the spark plug end of the coil, you can see that we have continuity through the secondary of the coil. The continuity check mainly tells you that you do not have a break in the windings of the coil. The true test for the coil is in fact a power test. So we have the black lead hooked to ground, the red lead hooked to the primary. Then we take a jumper and hook from the secondary to the air gap of the tester. Now, in reading the manual, number one, you will need to know the part number of your condenser, of your coil, and the test procedure. On this tester, we're going to want to turn the knob to the left, which is a spring-loaded knob, to the on position, and then rotate the indicator until the coil fires. We can take the reading and see that this coil is firing at about 51 on the scale. The coil must fire before it reaches 60. Now that's a quick and easy check for checking out a coil. The test booklets are written well so that the checks are easy to make and easy to understand. And it only takes you a few seconds to hook them up and make the checks to see if it's the ignition component itself that's causing your problem with the ignition system. In the program today, as we've looked at it, we've talked about basic theory of ignition systems, to timing the engine, to troubleshooting, and now to ignition test equipment. We hope that this program has given you different aids and directions to help you in the troubleshooting and the repair of Tecumseh ignition systems.